Section 11.5, equations that are reducible to quadratic equations. There are equations that are not really quadratic, but share their same qualities or characteristics. So for example, let's say we had x to the fourth minus 9x squared plus 8 equals 0. Technically, this is not quadratic because it leads off with x to the fourth. But we can manipulate it by breaking it down. First thing you should notice is that you look at these two x terms and notice how one power is double that of the other. Then this being my leading term, I want to convert it into something being squared. And we'll introduce the variable u to equal whatever on the inside. So x to the fourth can break down to x squared squared. This x squared can be raised to the first. So x squared is what's going in the parentheses. So we're not going to put x squared in because that takes us back to here. But we're going to put u in place of that x squared. And now we get u squared minus 9u to the first plus 8 equals 0, which is now technically quadratic because it starts with a u squared. And we can solve this for u. And then we'll turn around and solve it for x because we'll come back to this statement. So here, this factors. What two numbers multiply to be 8, add up to be negative 9? How about a u minus 8 and a u minus 1? Well, we know that this u is going to equal an 8. This one's going to be a 1. We're not done because we technically need to solve for x, not for u. So now we bring the x squared back into place. So we substituted out the x squared for a u. And now we're going to take out the u and replace it back with our x squared. So to solve these for x, we'll simply take the square root of both sides for both of those. We'll get x equals positive or negative square root of 8, which we can factor out of 4. The square root of 4 is 2. That will go out front. And here we'll take the square root of both sides and get x equals positive or negative 1. And there is my x to the fourth. 4 possible answers. 1, 2, 3, 4. That's what the plus or minuses, or positive or negative. All right, so we're going to apply these to other types of problems. X squared minus 1 squared minus 5 times x squared minus 1 plus 6. Do not distribute the minus 5. Do not FOIL this out. Look at your parentheses. Notice that they're exactly the same. This is technically to the first power. So since these two parentheses are the same, let's let u equal that binomial x squared minus 1. We'll take that out, replace it with a u. There's my new trinomial. So it goes from ugly to much better looking. Kind of like your instructor. All right, here we go. What two numbers multiply to be 6 and add out to be a negative 5? How about a u minus 2 and a u minus 3? We can solve those for u. We get u equals 2 and u equals 3. We go back, grab the x squared minus 1, bring it in for both u's, and now we'll solve each one of these individually for x. So we'll add over the 1 in both cases. X squared equals 3, x squared equals 4. Take the square root of both of those just like we did earlier. We're going to get x equals positive or negative the square root of 3. Really can't simplify this any further. And the square root of 4 is 2, so positive or negative 2. So remember, it's x squared. There has to be two answers. They're positive, negative. This even works with negative exponents. I'm going to let u equal the x to the negative 1 because this exponent is double that of this one. So this now becomes 2u squared plus u minus 15 equals 0. We'll go ahead and factor this. What two numbers multiply to be AC 2 times negative 15 and add up to be 1? Well, remember, 1's a great number. That means your two numbers are consecutive. So, seeing that it's odd, we need odd factors. Take the 2 times 3 is 6, and 5. 6 and 5 are your two numbers. So 6 will be positive, 5 will be negative. 2u minus 5, 2u plus 6. Remember, we used that 2 twice. This one has a GCF of 2. We'll take that out. We'll solve these for u. We're going to get u equals, let's see, add over the 5, divide over the 2, subtract over the 3. Now bring the x to the negative 1 back to the problem. X to the negative 1 comes in for u equals 5 halves. X to the negative 1 equals negative 3. So there's two ways you can look at this. Remember, this is technically 1 over x. And you could cross multiply and solve. And you'd get 5x equals 2 divided by 5, 2 halves, which would be 2 halves, which happens to be the reciprocal of this. And the easiest way to do that is just to make this power into a 1 by raising it to the negative 1 power. So a power to a power, that's going to become a positive 1. 5 halves to a negative exponent. We flip this, 2/5. Negative 3 to the negative 1. Flip this, 1 over negative 3. And then there's your two answers. So anytime you have x to the negative 1, you're going to go to x. You just take the reciprocal of what your x to the negative 1 is. We can have fractional exponents. Here's 2/5. It's double that of 1/5. So x to the 1/5 is going to be my u. So this becomes u squared minus u minus 2. We can factor. That's much quicker and easier. What two numbers multiply be 2 and subtract be a negative 1. How about u minus 2, u plus 1? Solve for u. U equals 2, u equals negative 1. There they are. Bring back the x to the x to the 1/5 power. We'll solve this for x. Now remember, this is a fractional exponent, so we're going to write this as a radical, the 5th root of x to the 1st power, which we technically don't need, and this is the 5th root of x as well. To undo the 5th root, you just take the power of 5 to both sides. So 2 to the 5th power, that will be 32. Negative 1 to the 5th power will just be negative 1. Now, we can grade this real quick. Another way of grading is by graphing. And the reason I'm going to say that is because these numbers are so far apart. This is ugly to type in, so let's not type it in twice. Let's just work with it once. So you go to y equals, you type in x raised to the 2/5 power. If you have an older calculator, you have to use parentheses around your exponent, minus x raised to the 1/5 power minus 2. Hit the graph button, but it won't fit in your standard window, so we're going to go to the window and change your x max from 10 to 40. So now when I graph it, I will see here's an x-intercept, here's an x-intercept over here. Hit your trace button, type in negative 1, notice it's equal to 0, that's what you want, and then while these numbers are on the bottom, you type in a 32. Y is equal to 0 again, so now we know that both of these are correct. A great way to check these, because sometimes one of these answers will not work, and sometimes both of them don't work. We just don't know. Okay, next example, 5 plus the square root of x is inside of both set of parentheses, so I'm going to let that be my u. So we'll have u squared plus 6u plus 2 equals 0. All right, this doesn't factor, so I'm going to go to complete the square. Remember what we did is the 2 is not allowing me to factor, so subtract it over to the other side. Put in your plus blanks. Plus blank here is half of positive 6 is positive 3 squared is 9. So the right side will become a 7. Over here becomes u plus 3 binomial squared. Then we can take the square root of the 7. U plus 3 equals a plus or minus the square root of 7. Subtract the 3 over to the front. And these are my two possible answers. Now, We'll take out the u, replace it with 5 plus the square root of x, just like we did over here. We'll subtract over the 5. We want to get the square root of x by itself. So subtracting over 5 makes that negative 8 plus or minus the square root is the way of, well, time out. Hold the phone. Square roots must equal positive numbers. The square root of 7 is somewhere between 2 and 3. So if we just round it up to a 3, negative 8 plus 3 is negative 5. Negative 8 minus 3 is negative 11. There's no way that these are going to be positive. So in this case, there is no solution. If we were to graph it like we did the previous problem, we type this into y equals, this graph will not cross the x-axis. Next, we have, holy cow, a trinomial x squared minus 4x minus 2 squared minus 13 times the trinomial x squared. Hey, these two trinomials are the same. That's my u. We take them out, we have u squared minus 13u plus 30 equals 0. This one, I believe it's going to factor. I need two numbers that multiply to be 30 and add up to be 13. How about 3 and 10? So u minus 3, u minus 10. Set those equal to 0, solve for u, which is just a changing of the sign. Now, not done yet. You got to bring x squared minus 4x minus 2 back for each u. Oh, I went from one trinomial to two trinomials. All right, it has to be set equal to 0. Subtract over the 3, subtract over the 10. Here's my two new trinomials. And they look factorable. What two numbers multiply to be 5 and subtract to be negative 4? How about x minus 5? X plus 1 set equal to 0. Change over the signs, 5 and negative 1. Two numbers that multiply to be 12 and subtract to be 4. How about 6 and 2? 6 will carry the minus sign, 2 gets the plus sign. They're set equal to 0. Add over 6, subtract over 2. There's my 4 answers. So again, you type in this left-hand side right here. When it's equal to 0, you graph it, trace it, type in a 5, negative 1, 6, and negative 2 in your window. You should get 0 for the y each and every time. In fact, let's go grab my calculator and we'll practice that real quick here. Alright, so y equals, whoops, let me clear that out. So left parentheses, x squared minus 4x minus 2 parentheses squared, and then I'm also going to show you another way to type this in, which is quicker, minus 13 parentheses x squared, where'd my, oh, it quit again, doggone it, reopen it. I apologize for that, so I'm going to go right to the quick version. You good for nothing. Ever since I updated my OS on my Mac, this thing's been struggling. Alright, here is another way to enter this. Because I don't want to type this in twice, I'm going to type it in once. X squared minus 4x minus 2. Enter. Y2, I'm going to type this in as Y1. That's going to make like my U. So I can get to Y1 by going, Alpha, you lousy rat. Scratch it, we're not going to do it. Okay. Do it in class. Ignore, get rid of it. Alright, next problem. 1/3, 1/6. Not sure if this is quadratic because, wait a minute. Yes, it is. 1/3 is double of 1/6, because if you take 2 times 1/6, you get 2/6, which is 1/3. So therefore, u is going to be x to the 1/6. See, u squared is 2/6. You square or double this, you get 2/6, which is 1/3. This factors, how about a u plus 3, u minus 1, u equals -3, u equals 1. Bring back your x to the 1/6. Well, this is just like when we had 1/5. We'll call that the 6th root of x equals negative. Wait a minute. That's an even root. Even roots can only be equal to positive numbers. Throw that out. 6th root of x is equal to a positive 1. Take it to the 6th power. It's still 1. There's my final answer. All right, I'm going to go try to get my calculator working. I might attach it to the end of this video.